Welcome back to Application Security Weekly. We just talked with Farshad Abbasi about building relationships between AppSec and DevOps to instill a culture of threat modeling and building software with OWASP's ASVS in mind. I'm your host, Mike Shima. I'm here with John Kinsella, and it's just about time for the news. But first, we'd like to welcome our new sponsor, SUSE. SUSE.io makes security tools for everyone. SUSE's flat rate pricing means you can set up SCAN DAST tools for your whole team. No seat counts, no scan limits, and you never have to talk to a salesperson. SUSE integrates with all common CI/CD platforms and supports most popular package managers. And thanks to SUSE's open source vulnerability scanner, license management suite, and SBOM generation capability, you can get back to what you really want to be doing, coding, in no time. Visit securityweekly.com/SUSE. Do you have a specific guest or topic that you want us to cover on one of the shows? Submit your suggestions for guests by visiting securityweekly.com/guests and completing the form. We review suggestions monthly and will reach out to you once reviewed. Also, don't forget to check out our library of on-demand webcasts and technical trainings at securityweekly.com/ondemand. And wow, thanks for your patience, John, to sit through our new our long list of announcements and ads there, because you possibly needed a little bit of extra time to check up on the news, because we've got quite a bit this week. So there is so much. Yeah, we do. Let's talk about some vulns. But what's the vuln that you want to start us off with?
Ooh, go pick a tab at random. No, I'm not. The one I got open right now is, more vulnerabilities found in Intel, ARM, and AMD CPUs. So this is back to, it's now being referred to as Spectra class vulnerabilities. These are vulnerabilities which in general, for those playing along at home, modern CPUs, as the ongoing, we're always trying to figure out how to make that CPU faster, right? We can't just increase your clock speed anymore. You can't just increase the number of cores in that die. This is, they were talking about this on the Apple stream last week. But so, what other tricks can you do how do you make that thing faster, right? So start doing software inside the chip. In this particular case, there's what's called speculative execution. So there's firmware running in your CPU, which is trying to figure out, well, the last time we ran these 3 machine codes, we then went and ran this other thing. So it starts doing it'll actually execute both parts of that in those 2 cores, and then whichever way the actual if test goes, it goes, and that result is already ready for you. So that was the original behind most of these things, several years ago. Someone over at VUSEC, I'm guessing it's pronounced, they figured out, so that was a vulnerability, or the class of vulnerability. Intel put some firmware in there to try and stop it. AMD the same. I believe the problem we had last time is they didn't have the ability to update these firmwares very easily, and now they've sort of smarted up a bit and they can. But still, with that protection in place, VUSEC has figured out a way to do what they're calling branch history injection. So it really just comes down to the same thing. It's all this classes. How can you fool that CPU into running a different branch of code, even if it wouldn't normally get run, right? So can you sort of game the system to get it to go and execute a bit of code, which you're not actually going to run, but what happens once you're executing that other code is it's going to do a scan through memory, right? Or you could have it do that. And it's doing that as a privileged execution. So what that gives you at the end of the day, what all this sort of babbling and talking is, allows you to see what is, it allows you to leak memory, basically. That should be kernel only. So that's what's going on here. When this first came out last week, it was claims to be an Intel and ARM thing. Then over the week, Intel was actually looking at why was AMD not affected? And they're like, it's relatively public code. Let's go and look and see what the other guys are doing. And it turns out that AMD was affected, so they let them know. And then the world found out about that too. So they've got patches out for it now, I believe. There was a number, not in this article, there's a number I saw somewhere early this morning. I can't find a link, but I think he was saying it was either AMD or ARM. My coffee hadn't kicked in, but for one of those 2 CPUs, the performance hit with the patch is quote unquote under 10%. Man, if you're taking 5+% of my CPU to try and minimize this type of thing from happening, or to mitigate it from happening, that's unfortunate, but that's sort of the cost of security, I guess.
It's really interesting that you wrapped that up on the cost of security, because I think the only thing I could effectively add to your great summary was the idea that this seems to be this class of attacks seems to be very sensitive for all the cloud service providers, because that's very much where you want this strong tenant isolation, and you don't want any cross leaking of memory or cross tenant access to memory. By the same token, there's also, we've seen effective implementations of the Spectre style attacks within JavaScript inside Chrome. And that's, in your browser is also just another area where there's plenty of secrets in memory, just very simply as cookies, for example. So, and I guess where I'm going with that is that possibly on the browser side, that 5% of CPU or that performance hit maybe isn't as big a deal. Although I possibly don't have as many tabs open as you do, John. So maybe I'm misspeaking here. But clearly on the cloud service provider side of things, 10% performance, that translates into the costs for the end user to running those containers, Lambdas, running all of those workloads in the cloud. So it'd be really interesting to watch how this class of vulnerabilities impacts the economics of computing.
It's interesting. It'll probably, just to talk about for a second, it's probably really going to hit the cloud providers, not so much where they're renting me a box, because then that's I'm paying for that CPU if it's a virtual machine that I'm renting an instance. But when I'm using serverless or functions where they're managing it for me, like a Lambda, if I'm getting charged per CPU time and per, I don't know, I guess it would still come back on me. That's going to be interesting to see if Lambda slow down. But okay, the thought I had there for a second was, if it's for the more managed services, the cost might actually be exposed to the cloud provider, not to the customer. But I might not be right there. So I don't know. Fun little thought experiment.
A good thought experiment. And we'll say, rather than say you might not be right, you're just speculating on this. So there's a couple of vulns in cloud service providers. So let's switch over to them real quick. And our friends over at Orca Security have been busy beating up Azure still. And they found a vulnerability in the Azure Automation service. And again, this is one of those types of articles that's is a great setup, because they find a vulnerability, but they also explain what is the service that they ran it in, what was a little bit of the researchers' thought process in terms of, this looks interesting, and then just unfolding that this looks interesting comment into finding a way to get, I think in this case, cross-account access, which is something you don't want to have happen. So, AutoWarp, I don't know how much. I didn't honestly read into a lot of the technical details of this particular one, because they're all nicely described in there in the article. So I don't know, John, if you've played with Azure.
Isn't that interesting? Because I did the same thing. There's another one we're going to talk about, which I did dig into. And I'm not sure if it's partially the gloss of this post, but I didn't find myself, I mean, they talk about it, but I didn't find myself sort of digging in and getting to the meaty parts on it. It looks like a good write-up. I don't know if I was either vulnerability'd out or Azure'd out or what it was. But I think between this one and the other one, the interesting thing to think about here from security in general, but particularly a researcher or a pen tester, with these cloud providers that are coming out with new products day after day after day and new features in existing products, man, you have to, just because you can't just go and pen test these things usually, right? Or you can do research, but you're only going to stumble over something if you just sort of take a quick look. You have to really know these things. Like the other article he talks about, he's spent a ton of times in this stuff. So that's I guess that's good and bad. If you specialize in this, you've got that specialty. But if you're trying to break into it, man, where do you start?
Yeah, and that's absolutely where some of the, all the foo goat, like the web goat, cloud goat, Kubernetes goat, I don't know how many goats there are out there, but those are by design great for understanding basic concepts, principles behind the cloud the CSP, cloud service providers. But wow, you're right. Getting into, here are another three new service names and icons that AWS has rolled out this week, let alone all of the others. And keeping up with that is interesting. And I guess part of the interesting part is just seeing how do they work? How are they put together? And this is the other, speaking of pen testing, from an article from NetSpy, was they were doing some review against the Azure Logic apps that are basically API connections to set up your service meshes, perhaps, or basically service-to-service authentication. And this stood out to me, which, once again, nice, good write-up, but it had my magic words of a path traversal. And essentially, if you do a %2f, which is the ASCII encoding for a slash, throw that into your resource group name, you've basically gotten the step towards game over. And to me, that stands out as just, how does a simple vulnerability like that happen? And it's a bit of maybe a mean question, but a bit of a rhetorical question, just in the sense of there are basics of normalize your data, then do your security checks. And whenever you're dealing with paths, whether they're within the URL, whether they're within the local file system, this seems like it should really be a solved problem, as solved as much as we talk about cross-site scripting or SQL injection is. So that's my sort of, it's maybe not quite a rant, it's my despair. It's something. There's an adjective I'm looking for. So help me out here while I try to figure out where my brain wants to go.
So I think what was interesting about this one is sort of exactly where you're focusing in on. So I have a tiny bit of insight on this, and this is the one, like, we were talking about. He as soon as I saw that ... I'm like, oh, I know I might pick this one. But when he starts talking about the Swagger doc and downloading the Swagger doc and using that, so the tell there for me, we have this functionality that I could use but I don't in Amazon's API gateway, where you upload your Swagger doc to it and it creates all the routes. And that I'm sure Azure has something like this, but generally the concept of a API gateway, for those out there who don't know, is it's sort of a proxy. It's something you put in front of your serverless, or it could be your servers, right? That you have like a set of APIs, routes for your APIs, along with the parameters, and when you need authentication or different things like that you can configure. But you can either pointy-clicky go and configure each one of these stupid things by hand. We use CDK. You can do it in Terraform, or all these different things. But the other way, for someone who's not using and you can probably doesn't matter if you're doing pointy-clicky or not. You can upload your, like I said, your Swagger doc or Open API doc, which is a YAML-based, or it can go either way, YAML or JSON-based document, which defines all your APIs. We've probably talked about it before, but you're able, once you have that document, you can either generate HTML from it, so you have like really neat, pretty documentation along with the ability to test and try stuff out, and then you can also generate clients, and I think right now about 30 different languages. But the point being here is, if that's what they're doing and they're just uploading that in there, that means they might not have the protections on the application code itself behind. So what he's really doing with this, by using the // as a resource group name, is he is bypassing the validator in the API gateway. But then it gets back to the code where he's not validating, or they're not validating. And there's, again, to sort of explain out a tiny bit what's going on there, what could be going on. If you do this in API gateway world in Amazon, and you have a Lambda, you would have to Lambda without any routing in it. Without giving away too much, there's other ways of doing that where you actually could have routers. You could have URL routers in your Lambdas, and then they're actually routing further off what's going on the API gateway. So that's my guess is what he found. And it comes down to a little bit of that. You can't trust the tools too much, right? It's because really what happens in the situation is you're trusting that third-party gateway to do the correct thing for you, but in this case, that didn't happen. So.
Yeah, so we all cry and feel assured that 20 years from now we'll still have job security within AppSec. But maybe one or two more vulns. Then there's a couple articles I think talk about the meta commentary, if you will, about vuln finding. So I think we have a good narrative unfolding here. But one, of course, Dirty Pipe. This is one that is a riff off of the Dirty Cow vuln, name-wise, from 2016, and it is a gnarly bug within the Linux kernel, and this particular write-up is really fun write-up. So it comes from a developer trying to debug an issue within some logging software on their system, and they saw that, hey, every once in a while these the logging gets corrupted. I've got these tickets, this other ticket, another ticket about this corrupted log file. What's going on? And so it is a really neat way of just that, rather than the researcher angle of, security researcher angle of trying to find a vulnerability, this is the developer angle of the debugging process. And they walk through about saying, well, it's usually never a kernel bug, but wait, maybe this is a kernel bug. They wrote up they talk about write up two programs to just dump a whole lot of A's, whole lot of B's through this pipe mechanism to see that, yes, they've worked it down to the simplest possible reproduction step to find that, in fact, there is a vulnerability here in how the Linux kernel is basically handling state, I think was one of the ways to say it within this data coming in from the pipe. And mostly the reason I really wanted to highlight this is that last week, John, you and I talked about looking at the fixes for vulnerabilities. And we looked at a fix for a vulnerability that was maybe 10 or so lines of code. In this case, the fix is literally a one line of code. It's in two places technically, but it's just initializing a variable to 0 within a struct. And it's stood out to me about why we have now such a impactful vulnerability whose fix is literally just initializing a variable, and how come the compiler didn't complain? How come a simple fuzzer didn't find this? How come a simple just linting tool didn't find and complain about this? So it's sort of why can't we have better tools? Is my wraith, shaking fist of rage at the sky after I read this article.
That does sound like something a linter should catch, right? And see, I would. That would be within. Obviously haven't written C for a while. Definitely haven't used linters in C for a while. That would be within the, reasonableness I'd expect a linter to catch. That is an interesting point. It's funny because I heard of this thing last week. I hadn't read this, which is, I believe, not believe, this is the original post of it. And I had seen another version on I don't know, Hackaday, I think, where they had the A/B example and they sort of went over it quickly, and I'm like, okay, cool, got it. Went on about life. And then when I was reading this one this morning, it starts very sort of, I had forgotten about the backstory on it. I'm like, wait, it almost sounds like, is he getting attacked, right? But yeah, this is, for those who haven't spent time in this, if you're doing this Unixy thing day in, day out, or really any type of operation stuff, right, this is how you'll frequently run into things like this. And it's like, one thing doesn't quite look right. And, if you look at the dates he had in there, where are they? It's over months that he's looking at this pattern. And you're usually going to blow it off. And at some point, you're like, okay, what's going on? And then as he started digging in and tracking, so I think that's actually pretty cool. It does feel very, very, very real. But yeah, as you were talking about that, Mike, there, the ability to set the default value or the initial value, I was thinking about Go and Rust and other languages where, again, this type of thing becomes less of a problem. We don't talk about that aspect as much as we do the memory safety and the other things. But, there's all sorts of good reasons, I think, to moving some of this stuff within reason and in time to more modern programming languages.
Within reason and time, yeah. Maybe we'll send it. We'll set up a betting pool with our listeners about what that time frame is going to be, whether it's days, months, years, decades, or centuries. Who knows? I suppose we'll be running into. Yeah, don't hold your breath. We'll be running into the time, the 2 to 32-bit time problem. before then. That's a silly tangent. In a not silly tangent, an article stood out to you. I'd actually read this article, but kind of just my mind just skipped over it about. Most orgs would take security bugs over ethical hacking help. So talk us through, why did this one particularly grab you, especially as we're talking about pen testing and things like that?
Yeah. A little unfortunate. And, part of the reason I threw it in, it's a little, I'll say it's not a super heavy article, right? And it's probably vendor driven. I'm guessing that the research behind it. But the reason I want to bring it in, here was to actually just get us all to think about, we talk about AppSec here every week, and you should be doing these things and these things. And, we had our guest on last hour talking about your CI and your blah, 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 blah. And we talk about responsible disclosure and full disclosure and all these type of things. But really, end of the day, keep in mind that outside our happy little world here, there's a lot of people that are like, I've got a mat by my front door. We're going to hide this underneath there. And that's the way they want to deal with this type of stuff. And sometimes there's business reasons for it. Either you need to get something else out or it costs or whatever else. But sometimes, a lot of times, people don't want to admit that they've got, those creepy crawlies in the closet. So that's the main thing I brought up here. But just to sort of talk through it briefly. What we're looking at is 65% of organizations surveyed claimed they would want to be seen as infallible. So that's point one. Of those, 64% said they want that they practice a culture of security through obscurity. Basically, you're not going to announce or tell people about vulnerabilities, which you've had. And I think if I go a little further, 57% of respondents to this survey said that they struggled to create a culture of cybersecurity, and only 26% were very confident that the staff were following security practices. Oh, and the numbers keep going down. 12% of departments outside of security and IT make cyber awareness and training a core focus. So I think if I keep going, the numbers keep going. But you get the point here, right? I brought it up partially because we talk about hack bounties and things like that for vulnerability bounties. And that's sort of part of what they're saying is like, I think this originally came from HackerOne. And they were saying like, hey, look, it's a good thing to expose this, but it takes a lot of effort to get people to really buy into that. So really, at the end of the day, the reason I put this in here is just tell people to keep up a good fight. And we're making progress. It'd be interesting to see what these numbers look like compared to a few years ago. But that's the all we can get out of this one for right now, and try not to hang our heads too much.
No, keep up the good fight. Roll out FIDO keys or any FIDO keys for all your developers. I think that'll be one of the greatest things you can do in terms of, they talk about like making cyber awareness and training a core focus. Just give your developers, especially the open source community. We were talking a couple weeks ago about NPM package owners rolling out YubiKeys. So strong MFA, probably one of the easiest things if we're going to talk about percentages. Maybe 100% of developers having using YubiKey type of or FIDO authentication for their MFA would be wonderful. I will switch to, speaking of sort of transparency though, we do often, or at least I am to blame for this, pull in articles from the Google security blog. Once again, I grabbed one. This is a little bit older, from March 10th. Actually, I guess it's not too old. It just feels like it. But they're talking about what's up with in the wild exploits. And it was just interesting in the sense of there's a transition of attack surfaces. And that's really what I wanted to focus on, in the sense of, with understandably no longer seeing Flash vulnerabilities, but now seeing a lot of Chrome vulnerabilities or Chrome 0 days. And I think I want to be maybe not overly strenuous, but I don't think this is to mean that Chrome is getting more insecure over time. I think this demonstrates that as we get rid of Flash, there was no such thing as a non-critical update for Flash, so we've gotten rid of that. Attackers have gone after where is the other big attack surface that lots of people use, and it's the browser. Everybody's using a browser, and that's why WebKit Firefox and IE, and of course Chrome is on here, and Chrome clearly has a market penetration, and so that's where the attackers are going after. And I think it just shows that for as much as we were talking about with Farshad in the last segment, you might have a company like HSBC that has a lot of money to invest into tools and to invest into engineering and security teams. Google, of course, has plenty of money that they can do, and they're building secure browsers with good architectures. But we're still humans. We're humans writing code, and that code has errors in it, as demonstrated by vulnerabilities that pop up. So this is not a sense of nihilism. It's more of a sense just to acknowledge where are the attack surfaces that we have, putting on that risk-based hat to think about what should we be protecting and what are different ways we can go after attack classes of Chrome. And I think that's maybe the final point I want to make on this. I don't think Chrome is responding to, oh, we just fixed this bug, we're good. They've been looking at how can we rearrange our sandboxing model? How can we do different IPC models and process separation? How can we adopt more fuzzing, for example? Even we were just talking about dirty pipe. There you could be running a kernel fuzzer if you want. I think Google probably running the syscaller fuzzing is probably the one responsible for fuzzing the most out of the kernel, and they do fuzzing on Chrome as well. So I guess the story is, it's nice to see this type of transparent discussion. It's nice to see them pointing this out, but I don't think it means that Chrome is insecure. It just means that securing software is really hard, even when you have a massive budget. So, that's me. So that's over to you, John.
On that, I think really briefly on that one, I know we got a bunch of stuff to carry over. Looking at the pretty picture, it was fun to see Flash go away. But I'm guessing that WebKit, I was just doing a little of the Googling while you were typing. While you were talking. WebKit also powers Edge, I believe, right? So I don't think that's so much we're seeing some interest in Safari. Sorry, say again?
Edge is on the Chrome. WebKit, anything on the iOS is using WebKit, but on Edge is Chrome, or the Chrome.
Okay, my bad. So so then it's that is just iOS or Apple at the top. These things are super difficult to do right. I mean, I don't know if I don't know off the top of my head the number of lines in any of the modern browsers. I know it's crazy high. So it's keep trying. They're doing stuff. I mean, it's not like people are sitting down and not like working on this like crazy and trying different ideas as we can, but it's still lots of work to be done. But let's keep going. We got other stuff.
It does, and I think it does. I will make the connection to you brought up the HackerOne article about bug bounties, and this is also one of the reasons why Google has such high bug bounties as well, because they want to keep Chrome secure, keep Android secure, and their other ecosystem, and those 0 days are worth a lot of money, and they reward it in that way. So, but we do have a bunch of articles. There was one that I first read through and skipped. Is like, I'm not quite interested in just yet another zero-click flaw, which basically just means no interaction flaw in some widely used UPS devices that can threaten critical infrastructure. And of course, the image for this has nuclear reactor coolant towers and a bunch of stuff. So it sounds scary. I was like, okay, no, not a big deal. But then I went back and reread it, and there's some nuances that I thought were interesting. So at a high level, there's a vulnerability here that's called TLStorm, or TLStorm, if you want to misunderstand the naming. It's in the TLS connections that essentially allows an attacker to intercept a connection. And because the application within this UPS device it doesn't handle TLS errors correctly, you can basically complete a successful TLS connection, and once you have that successful TLS connection, you can upload an encrypted firmware that's encrypted by a secret key a symmetric secret key that you've extracted from another device, and lo and behold, it will say, cool, I had a correct TLS connection, I've got some firmware that's been encrypted, I'm going to decrypt it successfully and install it. Boom, attacker has essentially full control over it. two things that came up. One was sign your firmware rather than just using symmetric keys. That probably would have been a little bit more helpful here. But this was kind of a supply chain of supply chain issues. So the vendor for this TLS library, Nano SSL is from Mocana, a name that wasn't familiar to me until I dove into this article. They talk about, it's a secure TLS implementation for embedded systems, essentially. And I even found back in 2009, there was a Black Hat article about a big old TLS SSL attack. And one of this Mocana, they were talking about their Nano SSL library. It was a bit marketing saying that we're not vulnerable to this because we use fuzzy. We know that ASN.1 parsing is tricky, and we use these length strings rather than just C-based length strings, null terminated strings, which ignore the marketing aspect of it. It's still nice to see that, yes, even back in 2009, they're doing string handling. They understand ASN.1 parsing is horrible, and they're using fuzzing as part of their SDLC. And they even wrote down in their manual for how to use their library, make sure not to ignore TLS errors. Well, you now have Mocana that's created a nicely secure, with a nicely described, at least, SDLC around their Nano SSL library. Another vendor implementing that library, not checking TLS errors, and now creating this type of problem for everyone who has deployed those devices. So it was sort of that interesting third party, fourth party, if you will, I thought, of secure software being used insecurely, and just why we're going to be talking about supply chain forever, perhaps.
I'm getting my Michaela Moroni not impressed meme to share on this one. What do you accuse say?
Pretty much.
I've got nothing to add. Next.
Yeah. Next. So there is next I think we'll throw it to you. There's either a couple articles, either car hacking, a Log4j, because we have to mention it once since I was the one who brought up supply chain, or flaws in package managers themselves. So which one should we worry about the most here, or I'd be excited about the most?
Let's see. What was so that one's good. I'll rip through at least two of them. The Mazda RX8 one for the car nerds is fun, just from the point of view of man, how easy it is for this dude to throw some stuff together. And I think there's a bit of hand waving going on in this video, but it's a 10-minute video on basically from grabbing a few components off eBay. He wanted to hack, he wanted to tune the ECU in his car. So instead of doing it in your car, you go and you pick up another one fairly cheap. You have the right components, you know what you're doing. And he's, doing twiddlies on the keyboard on his laptop, and you're seeing the speedometer and the rev counter actually start bouncing around and stuff. So it's sort of fun to see that and sort of realize how easy some of these things are to get into. So I posted it really for people who might be interested in looking for something else to hack or play with. That's why that's there. Log4j I'm mentioning for a change, just because I thought this was interesting. 40% of Log4j downloads are vulnerable versions of the software, according to the Maven Central folks at Sonatype. And the reason I really linked that there is I think what's going on is they're talking about the Maven Centrals, not so much the Sonatype repo, but how people are using those repos. A thought experiment of how do you, would it be within a realm of sanity for a vendor like that to come out and say, if we see the SHA for a vulnerable version, a known vulnerable bad version of a package which has been around for a while, we're going to blacklist it or block it? I know it's going to cause builds to break, and I know some people probably still need it, but how do you push people to get that stuff fixed? So that was sort of the interesting part of that. And then let's hit the third one really quickly. If you're using a package manager like most of us, these are mostly JavaScript package managers, but someone went and found a bunch of vulnerabilities, a bunch of different ones. So argument injection, untrusted search paths, a mixture of different things. So basically, composer, bundler, bower, poetry, yarn, PM, pip, and pipenv. If you're using those, it's time to patch. If you're interested in security for one of those languages, you might find some interesting patches in there. now. But yeah, it's someone doesn't know how to do this right. They could have had like their name in the news for a week by keep putting out a different one every day, and they announced a bunch of them at once. So thank you, and next time keep up and play in the security industry the way we do this, right? That's smart. Go on.
Yeah.
I think you have one more. Well, go ahead.
Oh, I was going to say, yeah, I've got one more, but you rattled off the list of the composer, bundler, et cetera. All those are running on your CI/CD pipeline, possibly with higher privileges. So it just kind of points out to like it's sort of important. That's where when we're that's where you want to be focused on your security. So anyway, I will try to sneak in one last article, a Telegram harm reduction for users in Russia and Ukraine. So I had, I've 1 or 2 episodes ago, I also threw in another article that we didn't get a chance to, talking about events in Ukraine and talking about if there is an AppSec angle to it. And that's only because I don't want to try and center AppSec on this type of environment, but situation. But here is where it comes in important. And here is this article speaks to me in the sense of AppSec as creating secure features or understanding how features can be misused, abused, and what the different types of threat models are behind them. And that's very different from the AppSec in the sense of the ASVS, the OWASP top 10, just the technical implementation. Did you make your linter happy, your SCA, your SaaS DAS tool happy? Ignore all those aspects and look at something like this and say, if our security advice is don't use Telegram, or just more generally, don't use X because I would never use X because I'm a security purist, you're not helping anyone. So that's really why I like both the specifics of this. Here's how to use Telegram securely and things to be aware of, but just the more general aspect of how do we help users who are going to make either decisions that we wouldn't make ourselves, but they make them because that's where their peers are within messaging apps, or because this is simply what's available to them. So that's really why I wanted to highlight this as a really good lesson for threat modeling as well.
There's probably an interesting white paper or talk there around the interaction between security and network effects. So network effects is a sort of a startup concept of if I can make my product be not just cool and people want to use it, but that it has the ability to share with my friends, and then like it expands through a network like that. It's a very sticky thing, a really great way to grow your product if you can do that. But exactly like, the example where you're just saying is my friends are using it. Okay, I can't just tell you to stop, right? Like I have WhatsApp on my phone. Everyone in the US is like, what in God's name are you doing with that? Dude, I talk to people around the world. And it's that same type of thing. I have tried in the past. I was a little more original. I used to say, I can't talk to you on WhatsApp. You have to go to, one of these 4 or 5 others. But really that doesn't work. That doesn't fly. You have to be it's the whole security versus usability thing, which is my life right now. But it's a good example of it. So it's cool that they put this out there. EFF is always great at this type of thing. So hopefully it helps people.
Yeah, hopefully it helps people. And I guess the final thing there I would say is, is you're part of a security team, if you have a trust and safety team in your organization as well, that's also the type of thing where there's a really good collaboration potentially to build up to understand just those trade-offs like John was just describing there at the end too. And speaking of the end, I think we've come to the end of this particular segment. Although I'll give you one last chance, John. Anything on the top of your mind or any teasers we want for the rest of the month about stuff you've been thinking about for articles to cover, discussions we could have with our friends in Discord? I know I'm putting you on the spot here, so I'm not sure if there's something on mind.
Man, that's quick. How quick is my mail going to search? Yeah, there's a fun one we didn't talk about. Facebook actually has a module out for doing code verification. So basically, if you've got something running in your browser, how do you know that that's the correct version? Like say React as an example. So that's sort of a fun thing out there. Yeah, it's. I think we're really enjoying having, thanks to the Security Weekly team, we now have the ability to see YouTube, Twitch, and Discord all in Discord where we hang out. So we get to actually talk to more of you. So really enjoying that and hoping to see more of you engaging with us more often.
Absolutely. Please engage with us more often. Give us a chat. Let us know what kind of articles you like and what kind of articles you'd like to see perhaps less of and more of. But we always want to see more of you, John. So thank you for joining me. Thanks to listeners for joining us as well. And please do subscribe. Give us a like. Check out the show notes. And if you're going to be doing some car hacking on that Mazda, also go listen to some synthwave outrun like Redline from Laserhawk. And with that, we'll see you next week on Application Security Weekly.